Magandang araw mga mag-aaral. Ako ang inyong guro, Daryl J. Mendros Balbin. In this video, I will use method of sections to solve a sample problem. A transmission tower is subjected to the wind load shown. Determine the axial force in kilonewtons in member GK. If in the problem you are asked to determine the axial force in a specific member, the ideal solution is method of sections. In method of sections, we're going to cut the truss into two sections using a cutting plane. However, you do note that, ideally, in a section, the maximum number of unknown forces should be equal to 3. Why? Because the free body diagram of a section may be a non-concurrent force system. We can recall that for a non-concurrent force system, there are three equilibrium conditions, namely summation Fx equal to 0, summation Fy equal to 0, and summation moment equal to 0. Three equations, three unknown forces. Therefore, the maximum number of unknown forces in a section should be equal to 3, ideally. How are we going to cut the truss in order for us to solve force GK? We're going to cut the truss this way. And call this plane AA. We may consider either the section above or below plane AA. Since the section above is simpler than below, we're going to consider the section above plane AA. We reveal the forces in the cut members and assume them to be in tension. We have force HJ, force HI, force GI, and our interest, force GK. Now you may argue that this is not possible because we have 4 unknown forces, whereas the maximum should be 3. Well, you'll realize that if we take moment at point H, HJ passes through point H. HI and GI also pass through point H. Therefore, these 3 forces create 0 moment about point H. Whereas GK is the only force that has a moment about point H. Therefore, by summation moment at point H equal to 0 alone, we can already solve for force GK. We now draw the free body diagram of the section above plane AA. We need to determine distance HG. And from our method of joint solution, we have known that this distance as well as this distance is equal to 0.6. And if this is 1.5 meters, this is also 1.5 meters. So we have 0.6 meter, 0.6 meter, and 1.5 meters. Therefore, the distance from H to G is 0.6 plus 1.5 plus 0.6. And that is equal to 2.7 meters. We also need the slope of GK. And from our method of joint solution, we have known that to be equal to 1 horizontal, 3 vertical, square root of 10 hypotenuse. Now we're ready to have summation moment at point H is equal to 0. Again, HJ, HI, and GI have 0 moment about point H because they pass through point H. Now to make our solution even simpler, we're going to resolve force GK at point G. Resolve force GK at point G. We have its vertical component and horizontal component. You will notice that its horizontal component also passes through point H, therefore 0 moment. Only its vertical component has a moment about point H. So we have GK considering vertical component 3 over square root of 10, and its moment arm from point H is 2.7, and it tends to rotate clockwise, so positive. And for the 3 kilonewton horizontal external force, its moment arm from point H is 1.8 meters. And it also tends to rotate clockwise. So this is equal to 0. Solving now for GK, GK is equal to negative 2.11 kilonewtons. The negative value means that our assumed direction for GK, which is tensile, is wrong. GK is compressive. This value is more accurate than the value we solved in method of joints, because here in method of sections, we did not round off our values to 2 decimal places. Therefore, this is the exact value for GK. Next, determine the axial force in member EG. How are we going to cut the truss? We're going to cut the truss this way and call this plane BB. We reveal the forces in the cut members and assume them to be in tension. We have force DH, force DF, force EF, and our interest, force EG. Just like in the previous problem, we have 4 unknown forces. But if we take moment at point D, you will realize that DH, DF, and EF pass through point D. Therefore, they have 0 moment about point D. Only force EG has a moment about point D. Therefore, by summation moment at point D equal to 0 alone, we can already solve for force EG. We may consider either the section above or below plane BB. Now, you may choose to consider the section below plane BB because you might argue that it is simpler than the section above. But I'm going to consider the section above plane BB because it is independent of support reactions, meaning that we need not to solve for the support reactions at A and B. We now draw the free body diagram of the section above plane BB. We need to solve for distance DE. From our method of joints solution, we have known this distance as well as this distance to be equal to 1.2 meters. And if this is 1.5 meters, this is also 1.5 meters. So this is 1.2 meters, 1.2 meters, and this is 1.5 meters. Therefore, the distance from D to E is equal to 1.2 plus 1.5 plus 1.2. And that is equal to 3.9 meters. We recall that the slope of GE or EG is 1 horizontal, 3 vertical, square root of 10 hypotenuse. Now we're ready to have summation moment at D is equal to 0. Again, to make our solution even simpler, we resolve force EG at point E. Resolve EG at point E. We have its vertical component and horizontal component. You will notice once again that its horizontal component passes through point D. Therefore, 0 moment. Only its vertical component has a moment about point D. So, EG, considering vertical component, we have 3 over square root of 10. Its moment arm about point D is 3.9 meters. And it tends to rotate clockwise, so positive. For the 5 kilonewton horizontal external force, its moment arm from point D is 1.8 meters, also clockwise direction. And lastly, for the 3 kilonewton horizontal external force, its moment arm from point D is 1.8 times 2, or that is 3.6 meters, also clockwise direction. And this is equal to 0. Solving for EG, EG is equal to negative 5.35 kilonewtons. Again, the negative value means that our assumed direction for EG, which is tensile, is incorrect. EG should be compressive. This is the exact value of EG because the values we used in our calculation were not rounded off to 2 decimal places. Rather, we used exact values. Lastly, determine the actual force in member FG. How are we going to cut the truss? we're going to cut the truss this way and call this plane CC. We may either consider the section above plane CC or below. Now I'm going to consider the section above plane CC because, again, it is independent of the support reactions at A and B. Now we reveal the forces in the cut members. For unknown forces, we assume them to be in tension. So we have force DH, force FH, our interest force FG, and force EG. For force EG, we already solved its magnitude and direction. Its direction being compressive. Now, how are we going to solve for force FG? We simply take moment at point H. Because at point H, both the forces DH and FH is at that point, meaning they have zero moment about point H. Only the forces FG and EG have moment about point H. We now draw the free body diagram of the section above plane CC. We recall that the slope of EG is 1 horizontal, 3 vertical, square root of 10 hypotenuse. And from our method of joints solution, we also recall that the slope of FG is 3 horizontal, 4 vertical, 5 hypotenuse. Let's have summation moment at point H is equal to 0. The 5 kilonewton force, force DH, and FH have no moment about point H. So we proceed with force FG. For force FG, its horizontal component passes through point H, so 0 moment. Only its vertical component has a moment about point H. So considering vertical component, FG times 4 over 5, its moment arm about point H is 2.7 meters, and the rotation is clockwise, so positive. Next, we consider force AG. For force AG, its horizontal component also passes through point H, so 0 moment. Only its vertical component has a moment about point H. So considering vertical component of EG, we have 5.35 times 3 over square root of 10. Its moment arm from point H is 2.7 meters, and the rotation is counterclockwise. So this is negative. And lastly, the 3 kilonewton force creates a clockwise moment about point H with a moment arm of 1.8 meters. So positive 3 times moment arm 1.8 meters, and this is equal to 0. Solving for FG, FG is equal to 3.84 kilonewtons, and this is tensile. You do note that in our solution, in order for us to solve for FG, we need first to solve for EG.